Saya mulai ya, Bu.
Ya.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Salam sejahtera bagi kita semua.
Ya.
My name is Rarasmaya, and I will be the moderator for today's session. We are welcoming all of the participants of the second week of the Adjunct Professor lecture series, and this week we will talk about IoT application. This event is held by the Department of Information System, Fakulty of Intelligent Electrical Engineering and Informatics, Institut Teknologi 10 November. I would like to welcome Professor Chou. Professor, thank you very much for coming.
Welcome. Happy to join.
I would like also to welcome Ms. Erma Suryani as the coordinator of this Adjunct Professor. Welcome.
Yeah, thank you very much, Bu Raras.
And before we begin, I would like to show some of the meeting rules. First, please use your full name in the Zoom meeting, and then please fill the presence. This link will be, we will present this link in the chat room after this. And then if you have any question, you can raise your hand or write the question in the chat room. And then the certificate of attendance will be available for participants who join the 6th class, and this is the 2nd class. And then another certificate will be added for participants who pass the evaluation. And then this is the schedule for today's session. And because this is already the second meeting, we will directly start the lecture session about 1 hour after this. And after that, we will enter the Q&A session. Adjunct Professor program is a program from ITS that aims to activate an international academic atmosphere in the ITS environment and to activate the culture of international publication, and then increase the number of ITS international lecturers and increase the ITS reputation in the world. And this is the profile of our honored guest, Professor Shuo-Yan. He is the director of Center of Internet of Things Innovation. His research interests are including IoT innovation, industrial IoT, big data analytics, artificial intelligence, smart city application, blockchain application, intelligent transportation system, entrepreneurship, decision theory, digital manufacturing, and computational geometry. And for a recap, last week we talked about foundation of IoT, in which Professor Chou showed us an introduction about IoT device and its several applications, such as what can we do if we combine IoT with computer vision. And today we will get more in-depth knowledge regarding IoT applications, how to regard IoT as an integrated system and not just an architecture. So let's not wait too long. Please welcome Professor Chou. Professor, the time is yours.
Thank you for the moderation, Rara. Let me share my slides. I think it should be this one. Okay. And swap. Okay. So can you all see me? See my slide?
Yes, sir.
Okay.
Yes, sir.
Okay, perfect. So last week, I think we have probably ended at this point. I just show you some sensors and how this sensing information can be provided onto whatever devices that we have. And the sensors doesn't have to be bulky, and the communication doesn't have to be wireless. In fact, for the IoT application, again, we focus very much on wireless communication. So even with such kind of sensors, look like tattoo, if you sort of put it on your face, on your body, they look like tattoo, but they are in fact sensors which have antenna, they have chips, they have sensors. Okay. And in fact, we don't need to look far. Now we have smartphones. Smartphone is a extremely complicated devices, and it provides all kinds of sensors, accelerometer, right? Gyro, proximity sensor, pressure sensor, haptic sensors, fingerprint sensors, all kinds of sensors. These sensors on the device can help us to support different kind of applications. You probably noticed that already. A lot of the tools, like if you want to do some like understanding the gesture, understanding the number of steps you are taking, and so on, and you can use the phone because all these sensors are made of MEMS, micro electromechanical system. They are small chips and mechanical system were integrated with the electronic system and squeezed into the small space of the smartphone. So more and more sensors, mainly for IoT applications, were created and integrated into our system. So phone in the past, even if it's mobile phone in the past, it is just a phone. There's no other function than talking to people through the line or through the wireless communication. But now the phone contains all these sensors within the phone. And with the interface that we have, in fact, this phone becomes an individual, a human connection with the rest of the world. And at the same time, interacting with the environment where the person is. Right? So it's, and also monitoring the person directly so that the information can be used for the person to manage its own activities, or allowing such kind of information being used by people who provide services to the individual. And most common one will be location services, right? Providing your location through GPS. Then a lot of services can be customized towards your location and towards your needs. In the past, this is almost not possible. Like every time we think of some application, then we thought, who will spend that kind of money buying a device just for that application? Although the application could be helpful. But then now with the smartphone, again, with the MEMS, all kinds of sensors, we can utilize this sensing technology and with wireless technology on the mobile phone. Wherever we go, we can have the information. We can manage our surrounding. We can manage ourselves. And I just mentioned that for Internet of Things, because we need to put sensors everywhere. And sometimes these sensors are on the object which are not fixed. They move, like human, like vehicles, like drones, like chairs. All these things move. So we cannot have a wild sensors. So they are already a lot of different kinds of wireless technologies, right? For networking, for telecommunication, or data through a telecom network. And they have different ranges, right? Long range, short range, and they have data rate. So different combination of the range and different with the data rate will serve different purpose of the use. A simple case will be RFID, which we saw. The range may not be too long, but the bit rate can be different too. Some can transmit more data, some only need to transmit small amount of data, but usually it's not too big. NFC, the range is even shorter because it's near field communication. And last time there was a question about whether or not well, what was the difference between NFC and RFID? Basically, they use the same components in terms of hardware, but in terms of protocols, one is just RFID protocol, basically reading. The other is communication, bidirectional communication. And of course, there are also Zigbee and so on, Bluetooth low energy, Bluetooth 5, and so on, different kind of wireless technology. They all serve different purposes. It's not that one is better than the other. Like short range has its strengths, its safety, security, but long range has broader coverage and may deal with a lot more items at the same time, but they are for different applications. For IoT, although some of the existing wireless technology can also be adapted for IoT application, but as I just mentioned, with the sensors detached from the power source, you want the sensor to consume as minimum energy as possible. And for a lot of applications, we don't need to have very high data rate transmission. So there's this LPWAN, low power wide area network technology being developed so that they can support easier access to the connection to the network. Some of the famous one include LoRa. There's a Sigfox, LoRa, and some other technology. LoRa is a unlicensed band wireless communication technology. It's just like Wi-Fi. Anybody can just connect Wi-Fi using its bandwidth. LoRa, as you can see, can transmit a long distance. In this particular case, it shows that it can be more than 1 kilometer radius. So you can have a very big range. You just need to have a base station, and depending on how many LoRa devices that you have, you can all communicate with the single base station. Okay, but the bit rate, data rate is very small, and you don't transmit it very often. It just if it's say environmental sensor, you want to measure PM 2.5, you want to measure for example carbon dioxide level, carbon monoxide level, and these are different sensors. Data can be collected from time to time, maybe every 15 minutes, 20 minutes, and transmit such data to the base station, to the cloud, so that the cloud can collect the information about environmental quality at a certain point and plot this information on the map so that people can see the overall situation of the environment in the region or in the country. Such kind of communication doesn't require Wi-Fi, not even, well, Bluetooth is too short. Again, these are just some example. Bluetooth now they can have mesh. Wi-Fi can have mesh too. Like Zigbee used to be mesh network, so Zigbee sometimes were being used. But LoRa, unlicensed band protocol, has been proposed and being used, and NB-IoT, narrowband IoT, which utilize telecommunication network, the bandwidth used by telecommunication, 4G network, and can also be used. It's safer because it's a licensed band. Company operating NB-IoT service need to pay for the license fee. So only they can use that bandwidth. In Taiwan, it's China, Chunghwa Telecom, which has NB-IoT solution. Oh, there are also other company, but they need to purchase the bandwidth from the government and use the bandwidth to provide service. User need to pay. But LoRa, the fee is very low because this is unlicensed band. The disadvantage of unlicensed band band is that it's not very stable. There could be a lot of interference, and there's nothing that you can do because it is unlicensed band. NB-IoT is dedicated band. So if people interfere your bandwidth, it's illegal. At least there's something that some way that you can deal with the situation. Now 5G also, one out of the three main characteristics of 5G is 5G may also provide NB-IoT functions, meaning that within 1 kilometer range, 5G may be able to receive 1 million devices connection. So you can imagine that if we have 5G network, we can have ultra high bandwidth, we can have low latency, and we may also utilize the 5G bandwidth to facilitate the needs of IoT, that is providing within a very short range of area, many devices connected. Okay, so 5G network now also trying to contribute to IoT application. So these are about wireless communication. But of course, if you are in the school, you have the environment, you have a lot of Wi-Fi access point, or the range of the data that you want to collect, maybe just close by, and you can still use Bluetooth, or you can use Zigbee. Zigbee has been used quite frequently. Okay, but again, Wi-Fi consumes a lot of energy. Right? It's not for every IoT device, or it's not for every IoT sensors that we need to consider. And 5G provide a lot of potential. I think 5G should be considered as not necessary to a level of revolution, but as 5G migrate to 6G and continue to grow, basically this kind of communication technology allow us to transmit very detailed information with very low latency, enabling a lot of application which cannot be very viable. And now with 5G or 6G, they will become viable, meaning that with 5G now, right now we don't have 5G, but if we have 5G and we can go everywhere, and we can transmit 4K video to the other side with high resolution. So when you are working from home and you are traveling anywhere, and as long as you have screen, and you will be able to communicate with other people almost like in real time. The latency is so short that you could not even sense it, and you can see this high resolution of the other side. Any subtle expression, subtle gesture can also be transmitted in real time, so that you can communicate much smoothly. Then people don't need to travel over the world and dumping carbon dioxide onto the earth. I mean, that I like to travel. That wasn't maybe it wasn't a good experience. I mean, traveling and meeting people are still important, but basically with the 5G, with the communication technology, we can suppress the difference of the location and suppress the time. So it is the basic of the revolution. That is, whenever we have major suppression of time and distance for human, it becomes a revolution. So 5G also have that kind of potential. And with the, again, I mentioned last time that it's not just getting data and storing in the cloud and not doing anything. We need to be able to process the data. So traditionally, we'll say that we'll use all kind of big data analytics tool. And as far as the development goes, we have more and more data, massive amount of data, because we have more and more sensors. Sensors built by companies, sensors from our phone. You can imagine, like camera is a sensor too. In fact, camera is a very powerful sensor. All kinds of data continue to be collected, and more data need to be processed effectively and gaining insight. All of them require this big data analytics tool. In fact, this morning I was in a meeting on Asia Silicon Valley development in Taiwan. So they are also trying to integrate government private data into a platform, and they are going to build an IDC, and they're going to, based on the data from IDC, they are going to build something called Intelligent Operating Center to help managing the city better. Okay, so basically we need data, and IoT provides data from the physical world, and these data, after being analyzed, will be able to provide insight for decision maker to manage the physical world much better. I think that's the main point. With the data, we can analyze them. With more data, better data, we can make better decision. That's the bottom line. And then, again, with the massive network, massive sensors, all kind of information need to be transmitted, and so on. And I think last week there was also this question of cloud computing issues. They are basically now there are also something called fog computing. Clouds in the sky, far away. Fog is surrounding us. So the computing environment will be surrounding us. There should be a system which can help the network to determine what needs to be done locally, what needs to be processed locally before it move up, when it should be moved up, in which channel, and so on. So the current intelligent network system, something like software-defined network, network slicing, network virtualization, all kinds of technology can be used to enable us not only to sense the environment. These data can be transmitted, can be analyzed and transmitted, or transmitted and analyzed effectively. Okay, so it's not just IoT. Is not just an infrastructure. IoT need to go to the stage where we can make sense of the data and try to use those data to support our decision, support our improvement, and support our responses to real-time situation. And these are the value of IoT. I usually tell people that although I said I do artificial intelligence, I do big data analytics, I do a different kind of research, but I always told people that I'm doing physical data analysis. I do not do say web page analysis. I do not do nowadays. In the past I did, but nowadays I do not do say customer relationship management, just focusing on transaction data only. If I want to deal with transaction data, I will try to get additional data from the physical world to help company to understand customers' true behavior and true preferences beyond transactions. So I also analyze transportation data. That we need to get data from the vehicles, from the movement of a vehicle, right? from the activities of the vehicle. If I say that I do health data, usually it means that I want to track the human activity and try to utilize that data to help human to improve on their health condition. That's why I define myself doing IoT innovation. I'm analyzing physical data, trying to improve our ability to better manage the physical world, including human health. And there are also different kinds of protocol because this is about connectivity. There are different organizations involved in IoT development. In the US, there's a Industrial Internet Consortium. Industrial Internet Consortium. It is a bottom-up approach, meaning that it's based on different companies getting together, forming this consortium, trying to define standards so that IoT application can be interoperable. They can communicate with each other, right? And so they have defined at least towards the upper level of the network layers, new protocols as potential standard for IoT protocol so that we can communicate. So this is a figure from IIC, Industrial Internet Consortium. Their standard white paper basically indicated something like these are as their standard, and it's not a single one. It could be like web services. It could be here is based on the telecommunication technology. It could be something called OPC UA Unified Architecture. It's basically from manufacturing. Originally it's UPC, but now they try to use different kind of OPC originally was Windows based. Should I say Windows based? Yeah, it is Windows based or DOS based. But now they try to allow different kind of platform using this protocol. So now it's OPC UA. And also data distribution service is also a different kind of protocol. It focuses very much on low latency communication. Just think of IoT communication. Some may be okay, as I said, about sensing the environment, 10, 20 minutes, having one data, and I think that's good enough. We don't need to have the data every second or every minute because it doesn't change that rapidly, or the change doesn't cause not much impact quickly. But for some application, once you sense some problem, the system need to react immediately without any delay. How do you guarantee the communication quality? How can you make sure that the sense and response can happen without too much lag? I think DTC is one of the protocol that can do that. Maybe currently the most famous one. It's basically like if you have in a power plant, you sense something wrong, you need to close the vault. You have to sense and respond immediately. If you are in the high-speed travel and you want to alert your crew to move in certain direction, the communication need to be very smooth, very quick. So they use so-called DDS protocol. So there are different kind of protocols for different kind of applications. And DDS used to be proprietary, but for IoT purpose, now it's open to IoT community. And so it is included in the IIC connectivity standards. Okay, so this is also a little bit on the technological side of the IoT. And the environment of the IoT is just as what we've seen here is it is the migration of the computer technologies from mainframe to it is a single computer, multiple user. Notebook is single user, single computer, single user, and smartphone came up, and then gradually we move to embedded system. Okay, so embedded system will be one person, single person, many computers, more or less. Even with smartphone, in fact, it's also like one person, many small computer putting together. But with the embedded system, is everywhere. Like one users are using many small computer to support the user's needs. So that's just the opposite of the beginning of the computer. Earlier, I also mentioned about ubiquitous computing. It is like this facilitated or enabled by embedded system. Ubiquitous computing, now we see that, we say, okay, it's just simple idea, right? Computing power everywhere in the environment. But in the past, when computer was just started, it is something that cannot be imagined. Only take a person with very deep vision, right? Can foresee that in one day we can have computer or computing power everywhere in our environment. That's ubiquitous computing, right? And embedded system enable that. Another thing that I want to mention is about a lot of traditional products which were numb, without any feeling, without any sense. For example, a car, right? Maybe most of us still think that a car definitely is a mechanical thing. It was, right? And particularly when it was using fossil-based energy. But now, a car basically is a complex computer on four wheels. Cars contain all kinds of sensors. Electric car is powered by electricity. It doesn't have an engine. It has battery. It has motors. And the rest of them will be just body. And then it has a lot of electronics, lots of electronics. In fact, until I think around 2015, on average, 30% of the cost of a vehicle came from electronics and software already. There is a prediction by 2030, or some predictions say that 2035, on average, for a car, 50% of the cost will come from electronics and software. For high-end car, it will be 70%. For driverless car, it could be up to 90%. So is it a mechanical product or is it an electronic product? Right? So it's just like our computer, right? Computer has this physical part, but it is computer, all the function, just like our smartphone. Smartphone has all kinds of apps which make the smartphone powerful, and all kinds of chips which might make the smartphone powerful. Cars will be like that in the future. There are a lot of new development on driverless car and the new use of the car. People sitting in the car, not driving. They are having meeting. They are interacting with the rest of the world. The car is the space that contains this person, occupy this person, right? Occupy the attention of this person. So the vehicle will be the main interface, right? When people are in the car, they are isolated from the rest of the world. they have to go to the car to communicate with the rest of the world. So it will become a very important carrier. It will be a prime interface between human and the rest of the world. So there are a lot of design, a lot of thinking about how to change the concept of car. What does the car need to do? I think later I will have some slides that I can share with you. Right now, the most famous car company is, if I ask everybody to type, I think most people will respond it with Tesla, right? Tesla's car, in terms of mechanical part, is not very good, but it is very good in electronics, APP, AI, all these things. And Toyota is making driverless car. Amazon is making driverless car. Google is making driverless car. And who will be the strongest competitor of Tesla? It will be Apple, because Apple has all these APP, all these functions, right? And Tesla, if you have ever see the function of Tesla, it's just like playing with a big iPad. Your driving is just like playing with big iPad. There's a Google map, you play with it and you set some function, the car will just go. You want to do anything, just play with the big iPad in the car. It's very strange feeling, in fact. Okay, so the world is changing. Like physical world doesn't have to be very like senseless, like numb. Physical world can have all these sensors. Physical object can have all the sensors. Not only understanding its own status, own behavior, it's also observing the outside, observing the environment, allowing you, the entity, to interact with the outside much efficiently, much effectively too. And in construction, buildings, we can also utilize RFID or sensors. Here they are, so that they don't need to be senseless again. The building is being built and everything there is numb, no sense. But now we can have all kinds of sensors. If some pillars tilt, we know. If the concrete was poor and move on too early, we can sense it. And if a worker fell because of the sensor on the helmet, we can know. When we want to pick up a certain item for the construction, and all of these parts look the same, we can use RFID and clearly identify that item. And we can count the object in the environment because we have camera as a sensor. There are many different kinds of sensors that we can use so that our construction work can also be more effective. It doesn't have to be numb and it was just there. Whenever we want to know what's going on, we need to have people going there, checking around, writing things, calling people. They can provide information to us constantly or continuously. There are some systems that we did. Some of them are quite straightforward. Like here, these drugs are controlled drugs. So whenever they are away from the shelf, we can know. And how many pieces of them we can know. That's just through RFID. This is for blood vessel. You want to put a bridge or to support to open up your blood vessel so that it won't get stuck. And in the hospital, they have these different sizes with different medicine coating in the shelf, but they couldn't find it. So we also did a work for putting RFID text on these boxes. Each box contains a different specification of the support that people can put into the blood vessel. So in the hospital, they can easily know for when they need to take a specific spec of the support, they can go there and find it. Otherwise, they spend a lot of time. Sometimes it is misplaced and they are in a hurry to get it. So that helps them to reduce the time for searching them and managing them and reordering them. And this is also something that a former student of mine did. Indy also know him. Basically, this is a very good example from my perspective. All the boxes, all the bottles has an RFID tag behind it. These are different grinded Chinese medicine, herbal medicine. So when you are trying to get a certain Chinese medicine, you need to get different herbals and mix them together. So when you scan your prescription, and there will be lines lit up on different locations. So you can pull them out, put them on a scale, and it will show for one box, one bottle. When you take the bottle out, the system will sense too, because you are not on the scale. Underneath the scale, there's a reader. So when you are taking it away, the system knows which bottle you took. And you scoop out certain quantity and put it back. The scale will also cross-check whether or not you took out the right amount. Then you take the second one and take the third one. After you finish them, you put them back to the right location. If you put them in the wrong location, the light will still be on. So you need to put them back so you will not misplace them. So the whole process utilize RFID to understand these are seemingly identical bottles, and experienced people may be able to do it very quickly, but a new person will need to search, and sometimes they will mistook certain bottle and mix them and so on, taking the right quantity and putting back in the wrong location and so on. But with this Chinese medicine rack with RFID readers and the RFID tag behind each bottle, we can ensure the process can be done more accurately. I think it's a very good use of the RFID technology in managing a specific work. Okay, so that is something that a former student of mine did probably 12 years ago. Okay, and IoT device doesn't need to work alone. They can work together to create synergy. For smart home application, this will be an example. This is Nest, something that Google purchased. It's for environmental control, or it is just a thermostat. It knows temperature. However, it is an IoT device, so it has the ability to communicate with other devices, and it is more like a gateway connecting to the outside world. So for the smart home example, you can imagine that it is a thermostat, so it is controlling the environmental, well, basically it's controlling temperature mostly. So user will turn it on, and based on the environmental condition, like outside weather and how many people are inside, and whether or not the person has different activity, so that the person want to have lower or higher temperature, and it's doing which day of the week, which time of the day, and so on. So Nest basically utilize reinforcement learning to learn the behavior and learn to change the temperature automatically. And whenever there's a change, whenever it doesn't satisfy the needs of the user will make changes, then it will get penalized. So gradually, Nest will be able to learn the behavior of the user, hopefully, right? At least to some extent. It doesn't require user to do the change all the time. And Nest can communicate with activity tracker. So activity tracker that I wore, and I went home, and my temperature is very high, and my heartbeat is very high, and now the thermostat, the Nest thermostat will know that maybe I want to have lower temperature, right? And the washing machine, that we place a washing machine, it has washer and dryer, and the washing machine will check with through the to Nest, communicating with us, understanding the current rate of the electricity, and maybe able to communicate with other devices and determine whether or not it should shift the operation to a later time based on the current electricity rate. That is in a lot of countries, electricity rate changes or varies based on the demand, or based on the schedule originally, but also based on the demand. So you don't need to get everything washed and dried immediately. As long as you can get them tomorrow morning, it should be good. So the machine should be able to communicate and get the information. And also, for example, if it's 5 o'clock in the afternoon, your car is within 3 kilometers away from home, so the thermostat know and change the temperature so that when you reach home, the environment is already suitable for you. So all these connectivity can create synergy and also other functions. So IoT devices, they also mentioned about IoT system should be a machine-to-machine system. It doesn't require a human to intervene on everything. The more sensors, the more IoT devices, the more sensors we have, they should be able to coordinate together to create a better environment fitting our needs automatically. The more sensors that they have, the better they should be able to do. But of course, last week there were also students asking the security issue, the privacy issue. These issues need to be addressed for sure. Okay, these issues are still being studied. It is a major ongoing study. So following the smart homes example, you can imagine that within a house, it could be different smart function you can have, right? You can have lighting following a person. You have environmental sensing, and you can have smart water dispenser, and so on. Maybe, let me see. Okay, yeah, you can have these different functions. Like sensors on your cup will remind you to get more water, and let's see. Okay, so wherever you walk, the light will follow you. In a lot of cases, we don't need to have lights for entire space. We just need to have the right lighting at the right place. And in fact, we know noise, air, these are pretty pervasive kind of pollution. In fact, lighting is also something that we don't need to have too strong all the time. Lighting, particularly blue light, will influence our body, right? Not allowing us to rest well, and will influence our body to release melatonin, and so that our body, our cells cannot repair themselves when they need to be repaired at night. So lighting is also an issue. Also for energy conservation, we want lights to follow people. At certain location, it should be stronger. At certain location, it should be in different color, and so on. And in terms of water dispenser, also we can use those smart functions, right? Communicating. If the water temperature is right, it will contact you. You will just go there and get the right right temperature, or after a certain time you haven't had water, you just bring the cup with you, and here there's a device which have water dispenser. The water dispenser will alert you and allow you to get the water, find the water dispenser. This is a home case. In the school we did something similar. Maybe later I will explain that. Also adjusting environment, more people going there, people walking all the time, people having high temperature and so on. We need to have better sensors. We need to have better sensor to adjust the temperature. And if we our ventilation system or our cooling system or heating system have more sensor, we should be able to allow the environment change more evenly. Or on the other hand, we may be able to allow the room to have different temperature, so that different people in the same room can feel comfortable based on their needs. And I think one time a student also asked a very good question. He said that, he said a lot of time we want to get the water at the right temperature, but before that we need to waste a lot of water. So if we go there every certain minutes, and we should be able to allow the water to change to that temperature, so that when we want to use it, it is at the right temperature already. We don't need to open the faucet and allow water to run for some time before the water reach the temperature that we want. That is also a good idea, and that can be done. That can be experiment. And here is an example of a coffee machine. It's a commercial coffee machine. Maybe I will leave it to you to think about it. With what kind of sensors and with what kind of service, if we turn this machine into an IoT machine? It is just a coffee machine, right? Need to think of different aspects of the needs. How can we make this machine to provide better service? How can we allow people using the machine to reduce his or her work while providing more services to people drinking the coffee? You can think about it. There are many possible applications, and they have been developed by many other people too. Okay, in fact, I have some example, but I think I will just skip it for now. I want to show you a few videos at this point. Let's see. So let's just say, if I'm asking you a helmet, we ride motorcycle, we need to have a helmet, right, to protect our brain, our head, basically. And although we are still injured, right, our hands, legs can injure, but our head is most important. It could be fatal. So we need to have a helmet protecting our head. So if I said that there could be an IoT helmet, what kind of helmet can you think of? An IoT helmet. Think about it. what kind of sensors do we need to have for helmet, which will be helpful, or what kind of innovation you can come up with? Maybe you can type on the messaging board. Like what kind of help sensors that we can add to the helmet, and how does it help us? Or what kind of problem that we have with the helmet, and how can we resolve that problem by using IoT technologies, basically sensors and responses. Oops, can you, oh, sorry. Oh, I have to stop share.
Yeah. Mr. Akbar said that we can add GPS, and Miss Andika Rabani said we can add gyro. And then I think we can adjust the brightness of the glass according to the sunlight.
Very good, very good. I think these two are very important function. Like people may fall and you have GPS, people can find you. And when you fall, you have a helmet. If you fall too hard, then people can also help you. Okay, I'll give you one example. This is, can you see the video?
Yes.
Okay.
Cycling is a big part of life in Sweden. About 80% of people ride bikes as part of their daily commute and for pleasure, but only a third wear helmets.
If I have been falling with the cycle, never on my head, so why should you wear a helmet then? I crashed with a helmet once, I just cracked in 2 pieces, so rather the helmet than my head.
When we were kids, we were learned to ride a bike, and we never used a helmet.
So 2 industrial design students decided to create a helmet that people would actually want to wear. The Hoopding was born and mixes high tech with high fashion for cyclists.
They wanted something more discreet, something that would go better with their personal style and not interfere with their hairstyles, for instance, a lot of vanity issues. And people were also asking for something invisible.
Unlike a traditional helmet, the Hoopding is wrapped around your neck, you zip it up, and you activate it. And now I'm fully protected and ready to ride.
The collar has sensors which analyze movement patterns 200 times a second to determine when a cyclist is in a real crash. When that happens, an airbag deploys and wraps around your head and neck. Each year, 300 people sustain head injuries in cycling accidents, and road safety experts say any initiative to protect riders is welcome.
In Sweden, we have like 20 to 30 killed every year. Of course, it's worrying. And we are working now to increase the helmet use.
Once the Hoopding is deployed, it can be reused. And at $540 a piece, some see it as an expensive investment.
It's a little bit expensive. It's probably more expensive than my bicycle. Okay. So also there's let me just show you another video. Oops, sorry. If I say that there are sensors on the umbrella, what do you think that the sensor can do?
Yeah, Mr. Benjamin said that the umbrella should be opened directly when there is rain. And Miss, yeah, Mariam said the umbrella will protect from sudden heats, and Mr. Adam said humidity. But maybe I think I will need an umbrella that don't need to be held by hand.
Oh, okay, very smart. Okay, so how does that work? Let me see. I need to share my screen here. Can you see it? Well, basically, it follows you. There's a sensor following you. There's a drum, but then you saw that is. Why would people want to do this, huh? This is why. Okay. And I think I like one video very much. It's about, let's see. It's about interacting with the physical world. And this is a very well done video. It's done by ETH. You can follow this. It's physical world. It's interacting with the physical world. It's like fantasy. Like how can you interact with the physical world? And they make it very, very interesting. Mind you that it's not animation. It's not animation.
I'm sorry, Professor, are you sharing a video right now?
Yes, can you see it?
This is your folder. I think we.
Oh, sorry. Stop sharing. And now?
Okay.
Okay, sorry. Oh, sorry. Not sure. Again, it's not animation, it's interaction. Could be gesture control, could be sensing, but there are drones within the lamp. As you can see, it's the interaction between human and autonomous flying machines. Okay, no CGI, computer graphics interface was created. It's you probably know this circus, very famous, and the school ETH Zurich, and so on. Okay, so the although this is supposed to be very technical, but I think IoT also can also be used for presenting something touching, something out of ordinary to human. So it's not just technology, it also enrich our feeling towards the physical world. Let me come back to the slides. Sorry, Raras, how much more time do I have?
Half an hour.
Still have an hour. Okay, perfect. So let me move on. So basically we have seen some like simple examples and smart home examples. Stop sharing first. And can we take a 3 minutes break?
Okay, yeah.
Sorry, 3 minutes break.
Okay.
Okay.
So for all the participants, we will have a 3 minutes break. You can maybe take a drink or maybe go to the bathroom. We will be back at 4 past 41. Thank you.
Thank you. Let me get some water.
Okay, maybe we can continue the session. Professor Chou,
Okay.
if you may.
Yes, yes, sorry about this.
Oh, no, that's okay.
Yeah, I had a very long sequence of meetings from 9 o'clock this morning until almost 4 o'clock in the afternoon. So I spoke too much. Okay. So for the video, what I was trying to show you is IoT is technology, and we talk about analytics. In fact, previously, I think most of the applications we talk about were about devices, more on the devices. Even on devices, the 3 videos indicates that with the ability to sense and respond, in fact, there are a lot of imagination that we can create, right? The helmet, like airbag kind of helmet, or the drum in the umbrella, which can follow a human and keeping the distance at the right location, keeping the distance. And also for the drama that you just showed, you just saw, it's also quite touching. I think there's just a lot of imagination that you can have. But more and more, I'll talk about IoT as a system, meaning that it has to create some services, provide some value. And before that, this is another a device that we have utilizing IoT tremendously. That is, once a car is connected, once the car connect, IoT system help us to connect the physical world, as I try to phrase it. Once a car is connected, there are many changes to the car, many new changes to the car. Original for the car is a mobility, for the mobility purpose. Get in the car, you drive the car, it has to be safe for sure. But the main purpose of the vehicle is for mobility, transporting human or some other object from one location to another location. With the connected cars, the vehicle could be the place where we focus a lot on entertainment. As I said, yeah, you will be in a car, self-driving. Okay, that's also a new function on the vehicle, driverless car, and more, at least for public transportation, in places where it is less likely to create injury to human. I think more and more they are replaced directly with self-driving vehicles. It is a place where we can provide data and being tracked. It is now super safe because it has a lot of new sensors which can prevent any harm. It helps to manage our life because we have time there, and the system will be able to interact with us or with our home. As I show you an earlier example, before you reach home, a car will tell the home that you are going to return home. So the home will be able to prepare the environment for your return. Maybe not just the temperature, it could be the rice cooker start to work and water start to boil or something. These are different things. It helps you to manage your living too. And right now, when you are driving a car, basically you still need to make all kinds of decisions, not just driving decision, going to where, how to go. Maybe Google can help you. Since the Google Map can help you, the car can have this ability. So it's self-sufficient. With the electric car, now people say that without the charging station, people driving electric car has this range anxiety. They don't know whether or not with this car they can reach their destination, and where do we have this charging station. So your car should be self-sufficient. When you want to go from one point to the other point, the car will route for you so that the car can ensure that it can be charged at a certain location so that you can still reach your destination. It has to be self-sufficient. In the past, there are gasoline stations everywhere, and once you fill up your tank, it can go for certain mileage. It's quite certain, and before that, you can find another filling station. But for electric car, it has to have this function to reroute your travel so that it can ensure that it can bring you to the destination. And when you are going home, going to a different places, the vehicle can do that. You can tell that The vehicle is serving as an interface between you and the outside world, or bring the outside world to the vehicle for you. Once the car is connected, I think the connectivity is very important. The connectivity is not just sensing and not being able to connect, right? You need to connect to the rest of the world so that the service, the knowledge can be communicated, so that the car will not just provide, not just the car, the object will not be just providing very limited service to the person. And we can turn a passive safety car to an active. Passive meaning that you have an accident and airbag pop, right? You have safety belt, you have accident, safety belt protect you from more severe injury, and so on. But for active safety, it means that you will prevent the accident. So you have all kinds of sensors on the vehicle. The vehicle will see the environment, understand how to respond to the problem in the environment to keep you safe, to keep the car from wrecking, rather than after wrecking to protect you. So that is also something which has already been proposed 7-8 years ago. And the street will be quite different. On the street, we can build up intelligent transportation infrastructure so that vehicle and vehicle can communicate. Vehicle and infrastructure can communicate. Human and infrastructure can communicate, so that in a specific case, when a person is walking towards a certain location, which the car cannot see, but the infrastructure can tell the vehicle that there's a person there to prevent it from accident. When I think a lot of people are talking about like fire truck or ambulance moving along, how does the rest of the vehicle knows, how do they yield the road to the ambulance? I think one of the solution will be the ambulance. As ambulance is moving, ambulance send the information to the infrastructure broadcast the information to the rest of the vehicle, so that they are aware that there's a car in their Google map. They can show that there's a car in front of them or coming from which direction, so that they can avoid the vehicle. Okay, it's also they can adjust the traffic light. I think there is also such a solution. But basically, vehicle can know what other vehicle will behave. So ambulance or fire truck can also see how other vehicle behave. So there are many functions that can be integrated for intelligent transportation system, particularly with the driverless car, electric car, and particularly with a lot of so-called smart street lamp. Because you want to have sensor, you want to have wireless, you want to have communication technologies, networking technologies there, you need to have electricity. So street lamp has electricity, and it is maintained by an organization already. And it has lots of space and can be quite higher up by the street. So it is a very good basis for expanding to an infrastructure for intelligent transportation system. Many countries, including Taiwan, has such kind of solution. Turning street light. Well, street light, first of all, you can change the traditional lighting to LED lighting, and you can control, you can have a sensor deciding whether or not they should lit up. Even though it's 4 o'clock outside, but today it's very cloudy, so the road condition is not very good. You don't need to have people to turn on the light. The sensor will trigger the the street lamp to lit up. Right. So, and wireless communication technology allow people to communicate and vehicle to communicate and so on. Again, these are based on sensor and based on wireless communication technologies will be able to provide a lot of services. And also between car and car, they use LED to transmit data between vehicle. LED is also the digital form, although it's lighting, but it can carry information as well. So, or using those LiDAR to communicate. If, let's just say, if you cannot see this car, chances are your information do not need to be known by this car. So sometimes without line of sight, sometimes the disadvantage for certain application, it is the advantage. You don't need to broadcast to all of the car. You just need to communicate with the car that see you, which means that they may be able to bump into you, and they are other cars are responsible for their neighbors too. So there are also technologies developed for that purpose. LED communication, because if they cannot receive your lights, they cannot receive your data, and they don't need to know. So that's also some kind of technology that can be used. I think for me, the most useful IoT application is exposing the location of the public transportation. I took buses to the school, and in the past, some buses came every 15 minutes, some maybe faster. And during the course of the day, sometimes it's 20 minutes apart, sometimes 5 minutes apart. I couldn't remember all of them. So every time I go out, it's just taking chance. Like if I go there, it's there. Very good. It just passed. Then another 10 minutes, another 10, 20 minutes. It is a mass-produced service. So you go there, you need to fit its schedule, and you don't have control. It come. So now with the sensor in Taipei, we have this not as nice as it is, but it's quite nice already. And using our app, we can see when exactly it will come, and the next bus, and all the bus, in fact, on the line, you know where they are, and they have estimated time. Now I have a senior design project student, or we call it capstone project student, trying to improve on the accuracy of prediction, the arrival time prediction of buses. But at least we know that it's 3 stops away, 5 stops away. So every time I go, it's right before the bus arrived. Maybe a little bit earlier, but definitely it's not guessing. I know it's 3 stops away. Maybe you will arrive earlier, maybe you will arrive later, but I know pretty much where it is and how far away it is. So it helps us to utilize public transportation better. Although it is just public transportation, the number of vehicles could still be the same. But for you, it's so punctuate. Every time you need to go, it will be there. So it's more like customized service. So that improves the service level very much. There are many ways to expose the location of the vehicle. It's not just GPS, but because GPS in the metropolitan area, it will be blocked by the building. So you may not be able to know where it is. And if it's inside the tunnel, so there should be a combination of the technology. If you really want to make sure that you can know where the bus is all the time. Okay. But if you just say that, well, most of the time it worked, sometimes it didn't work, it doesn't matter, then maybe you can use just a single technology. It is also a concept that will gradually come to is sometimes we need to use sensor fusion. we have multiple sensors, right? Sensor fusion to create better effect, and that is also quite important. That's also later I want to talk about digital fusion using different digital technology, not just IoT. We may still need to use other digital technology to enable the service, or strengthen the service, or enable the services of IoT, or enable the service of the physical to serve the physical world, or solving the physical world problem. So this is for the bus, very nice. When it's going to arrive, whether or not it's crowded, and so on. And even so at home, okay, at home we can just look at the information too. And it is not that easy to set up a post by the street showing the bus location. It is very difficult. In fact, in Taiwan, to put in Taipei City, to put a post showing that information, you need to go to 12 government agencies to get permission, to get data all together before we can put on the post. It's very, very difficult. But once we have that, it's quite convenient. People are quite happy with the information of the arrival time of buses. So we can see that too. And with that, we can even whoops, sorry. We can even whoops, didn't work. Okay. Yeah, we can even make the bus schedule more sparse, but maintaining the same service level, right? I mean, for me, it doesn't have to be every 5 minutes. 10 minutes is fine. As long as when I go there, the bus is there. So it doesn't have to be that dense. It can be a little bit more sparse, and it will serve the purpose, because there aren't that many people taking that route. If you make it too dense to create that kind of service level, it is a little bit wasteful. So you can make it more sparse, like from 5 minutes to 15 minutes, but people know when exactly the bus will arrive, so they can catch the bus all the time. So that can even help to reduce the cost for bus services. Not sacrificing the service level. We still want to keep the same service level, but we want to find different way to keep the service level. Right? Find different way to keep the service level. So we want to provide the information to customer so that in terms of the management, in terms of perception, is still satisfy the customer. It can still satisfy the customer needs. Okay. And we can also coordinate the traffic lights. It's not, it definitely is not that difficult. I think more and more it's more complicated. Meaning that when the bus is coming, if the traffic is not that heavy, there's no car on the other side, they can change the traffic light, allowing the bus to arrive the bus station. Okay. Later we'll also see in the future for the driverless bus, for the bus which is electric bus, and again, bus is just like a small car. It will become a very important vehicle for the people inside the vehicle to communicate with the rest of the world. So bus can communicate a lot of information with the bus stop. Like how many people are in the bus stop. People at the bus stop can also know how many people are in the bus. And earlier we see that they know when the bus will arrive and so on. It's also, and I also mentioned about traffic light control. And in fact, it should be traffic control for all the traffic control for allowing ambulance and fire truck and emergency vehicle to travel more smoothly and more safely on the street. Okay, that can be coordinated. But again, it's a very complicated issues. Traffic light is a very important facility. So the safety of the data, the power of the traffic light, and so on is very is not something simple that we can easily change. But with IoT, gradually, I think we can also make some improvements to improve on the traffic speed of the ambulance and other emergency car. And I think in a lot of parking lots, we have seen such kind of function that is you can they help you to find your car. Okay, help you to find where your car park. I'm not sure why it has to be like that, but in Taipei there are parking lots, big parking lots, and on every 3 cars there are cameras. So the camera can see your car. If you park at a certain location, it will take your photo and you use the license plate recognition software and record information in the system. So when you return to the parking lot, you couldn't remember where you parked your car. You can just type your license plate number. It will show you where you park your car. I feel that it's quite costly because like every 3 car there's a camera facing this and facing that, but that is already not that rare. I think quite a few parking lots have that kind of services. Of course, there are also outdoor parking. If you know that if your smartphone, if you use Google Map, and when you leave your car for business, when you return, you forgot where you park your car. Okay, in fact, your phone knows where you park the car, because as you were moving, when you stop for a while and maybe certain action, your phone will detect that maybe you have parked your car because you were traveling quite fast. Now you are moving very slowly. So meaning that you have left your car and walking, and your dangerous friend, your smartphone, will record your location, and you can say, oh, where I park my car, and they may guide you to the location. It's quite dangerous too, but that is also the function. Once they have sensor and they can deduce different kind of situation, then they may provide additional service.
I'm sorry, Professor. There is only maybe 5 to 10 minutes left.
5 to 10 minutes. Okay, no problem. I'll go a little bit quicker. And for the healthcare, so I'll talk for another 5 to minutes, or I should allow students to ask question. I'm not sure.
Yeah, that's okay. Maybe you can talk about 5 to 10 minutes.
Okay. So again, this is something called a smart medicine box, designed and made by a colleague of ours in the university. You can probably tell that there are 7 different compartments. Each one of them, if you open it up, take it out, it'll be like this, and you had like 4 compartments. Each one, it represents morning, noon, like breakfast, lunch, dinner, and before bed. So once you open that compartment, the signal will be recorded, so that when you go see a doctor, I mean, if you go see a doctor prescribe some medicine and you brought the medicine back, after one month, you go back to the doctor examine you and say that, the condition hasn't been improved. I need to increase the dosage. But the reality was you did not take the medicine. At least you did not follow the the prescription to take the medicine. But how would the doctor know? How would you know? Probably you won't record them at all. But with this kind of devices, every time you open it up, assuming that you are not gaming the system, that's the time you took the medicine. So after 1 month, you go back to the doctor has the record and maybe even being analyzed a little bit. So doctor can compare your conformance to the prescription and your new examination result and decide what to do. So it makes your behavior more transparent to the doctor so that the doctor can provide better treatment to you. Before having this kind of medicine box, doctor would not know. You will not know that clearly. And that makes the medical service more like a mass-produced medical service. Although doctor see you individually, but doctor doesn't know too much about you. So the treatment will not be too precise. But once the doctor can know how you took the medicine, or doctor can know your activity, what you add, and so on, all these information can be combined together so that doctor can make better treatment. That is also collecting data from the physical world so that the healthcare activity can be conducted more effectively. And for health check, I also feel that they should have this indication so that I don't need to line up for a long time and while the other place is empty. I think that's also quite helpful. Or I think maybe a lot of you still do not need to see doctor often, but with chronic disease, you need to see doctor every month or every 2 or 3 months. Every time you go there, you get the number and you don't know when you should go there. And you could need to wait for hours before you can get doctor, see the doctor, and doctor will see you for less than 5 minutes. So a better way is better predict when you should be there, right? That's also a physical world information. How many people are there waiting, and the system can even gradually make the prediction. I think later I will also talk about similar application that is making better prediction based on AI on when you should go there. Okay. Right now they have a assessment. It's, 54. Doctors see one person for 5 minutes, so 50 or 250, 60 minutes, 70 minutes. So, okay, you should come after like 4 hours, like from the beginning. But that's not very accurate. So basically that can be done. That can improve our health service, making health service more like personalized service rather than mass-produced service, similar to transportation, even public transportation. We can, with the data, knowing precisely the service of public transportation vehicles, and we can turn the service from mass-produced transportation service to more personalized transportation services. Okay. Oops, sorry. Maybe I use this as the last slide for today. So this is also something related to sustainability. A lot of work we are doing using these technology to solve problems, but mostly are dealing with sustainability problems. Very few of my work is dealing with commercial problem, like business generating higher profit, that kind of the work. A lot of them are dealing with sustainability. So this is LED light bulb. LED light bulb, comparing with the traditional light bulb, can save a lot of electricity. But the semiconductor part of a LED light bulb, if you throw the entire light bulb into the garbage when they process it, more than 90%, maybe even 95% of those hazardous material cannot be recovered, cannot be get rid of. So this is a design from a company which you can push the needle to replace this core part which lit up the lights. So when you use this kind of light bulb, when it's about to break, this light bulb will communicate maybe through your smartphone to the company. The company will mail you and a replacement. You just need to push the button and take it out and replace the new one and put the old one into the package and send it back to the company. Because it's separated from the light bulb, you can recover most of the hazardous material or important material from the LED light bulb. So it is also a good example of in order to support sustainability, in order to allow more people willing to use a certain new technology, you also need to consider their problem, their needs, and through IoT allowing you to reduce the user's burden by replacing the light bulb and also support a more sustainable usage of the LED technology. Okay, so it's also through connectivities. Okay, I think I will pause here and allow students or anybody to ask questions.
Thank you very much, Professor Chou, for the very interesting presentation. I'm sorry for the limited time.
No problem.
But yeah, but I already shared the material for today's session in the chat room.
Okay.
So the participants can learn about other interesting application of IoT in the material.
Yes, yes. Okay, that's good.
Now we enter the question and answer session. I will invite the participants. If you want to ask a question about Professor Chou directly, you can use the raise hand button, or you can use the chat feature. For now, we already have several questions.
Okay.
I will read it. First, from Mr. Afif from Universitas Trunojoyo Madura. He asks, due to the pandemic we face today, could you please describe your forecast on the future of IoT implementation in developing countries?
Oh, in developing country,
yes.
I think we need to think. I mean, IoT application is a technologies that we use to help us to understand the environment, right? Based on this, if you think of pandemic, one thing that people use immediately, which also cause a lot of concern, is about contact tracing. You know, the situation pandemic, if I found somebody is infected, I want to check what other people this person has been in contact, and how would we know? How would the person know? And we need to quickly inform these other people so that they are aware that they are potentially infected. They need to be self-quarantined or seek help rather than moving around and spreading the virus further, right? That is a very important mechanism. And including South Korea, in Taiwan, I don't think it's being used. That is use contact tracing. But there are also a lot of ways that we can do. Right now in Taiwan, if you want to get into any place, any public place, or like restaurant, convenience store, government building, school, any independent facility, they have a barcode there, a QR code there. And you can use an app created by the government. You can scan, and that's the location basically. Scan and send the information to the government, and the timing was recorded as well. And then government will help tracking this. every 28 days, they will delete such information. Okay, but if they did not delete, they basically know where you are, which store you enter. Maybe even later on, they can connect to what you bought and these different things. So people have concern like this. I think after pandemic, people are relying more and more on the digital technologies. I can foresee that, well, I'm not a fortune teller, so I shouldn't, I cannot really be sure, but basically my feeling is in the past, we are more reluctant on trusting the digital system or facing the digital system. But now, because of the constraint of the pandemic, there's no other way. And now we are used to the digital system, although for sure using digital system has some disadvantage. Yeah, some potential threat, but then there's no other choice. And once people started to accept that, the massivity to such kind of technology will be reduced, so it will be more prevalent. I think a lot of such kind of digital technology will be adapted, and of course it will. I can almost see that it will create a lot more problems too. But that's yeah, nothing comes perfectly. There are advantage and disadvantage. I think later I will talk about the threat of the all the connectivities. Right? The World Wide Web, in fact, is creating a lot of problems nowadays. Create problems that that we may not even be able to manage nowadays. Probably did not answer your question.
Yeah,
but
thank you very much, Professor Chou. Mr. Afif, I hope that answer your question. And then for the next question is for Mr. Benjamin. Actually, he asked two questions. The first, maybe I will read the first question first.
Okay.
Yeah, the first question is about the danger of exposing human to a lot of radio frequency. Does it really safe for human to go around with a lot of radio frequency around us, or it's already proven that it's safe? He heard that 5 gigahertz radio tower sometimes emits radiation above normal, and yes, people can sick because of the radiation.
I don't know precisely. Okay. But but for sure, I think people suspect that radio frequency, if you are exposing to stronger radio frequency, is not good for your health. But I think the government tend to support that. That is why there are a lot of, I mean, every time you want to put a base station there somewhere, and people living around that area, because they are too close to the base station, they'll protest. And the problem is for the telecommunication company, because the strength of the signal can be controlled. If the signal is too weak, they need to have denser base station, which will be more costly. So they want to reduce it to the range which is considered safe, but they don't want to reduce it too much to the extent that it doesn't have good reception. So there's a balance between these two. But radio frequency, a colleague of mine doing electromagnetic research, I was asking him about the same question. He said this jokingly. He said that, what do you think if you stick your head inside a microwave? If you cook long enough, definitely it will have some effect. So radio frequency, including RFID, which is very weak, I think smartphone it's a lot stronger, and you are putting right by your head. It's a lot stronger. So if you are worrying about this external system, again, there should be a balance. Even if it create harms, I think there are regulation, or if the regulation get enforced, it's still relatively safe. But if you are using your smartphone all the time, it's more like putting your head inside the microwave all the time. And even though it is turned on very lightly, but in the long run, it's still not good. Okay, I'm not an expert on that, but basically, it's, I think, for sure, if it's too strong and in certain frequency, like microwave frequency, it will cook you for sure. So if it's not too strong, I think it's still inconclusive. Like how long before it will cause harm? I don't know where the exact boundary is. Sorry about that.
Yeah, that's okay. Yeah, it's
Second
yeah,
question.
answer in a way. Yeah. But and then the second question is about with the massive sensor. I think this is about integrated transportation system with that massive sensor. Is there already a way? Is there already a strategic way to maintain the sensor for a certain time, or will it be kept forever and only get software update?
Oh, sensors. Oh, I think the sensors basically sensor is like we call it silicon, using silicon materials. Until now, it's about 10 years. But if we consider the battery, depending on how much energy it's going to consume. For example, if you use a beacon, Bluetooth beacon, right? Bluetooth beacon, I think some company claims that if you don't want, again, you can adjust the radio frequency, how strong the signal will be. So if you do not need to send the signal too far, right? Detect the signal, you don't send the signal too strong, let's just say, then it can last for 2 years. So there are different, like if you have this active sensor, meaning that it has battery and it sends signal out all the time. It depends on how frequent they need to send the signal, how far they need to send the signal, but it will consume out the battery. So the battery technology is definitely an issue, but the energy consumption is also an issue. So you may be able to find different way to consume the energy. For example, when you are not sending, you sleep, right? And if you use LP WAN, low power wide area network, then it consume less electricity, then it will last longer. There are also different kinds of energy harvesting technology, allowing the battery to be recharged. Well, it doesn't need to be very sophisticated. It could be a solar panel collecting solar energy, converting this irradiance into electricity and charging your battery, or powering your sensors directly. Or it can be vibration energy harvesting, so that it can harvest from vibration, it generate the momentum and so on. It will create this electricity, and it can be this piezoelectric, right, with the plastic and contraction that will generate energy and doing this energy harvesting. So either you have good battery, consume less energy, or you have energy harvesting technology. Otherwise, you need to replace the the battery very often. For certain applications, which does not allow you to have shortage of electricity, they may still need to have power cord to get power. So there's no solution, there's no sensor running forever without energy. Oh, if it's passive one, it's not sensor. RFID tag, it could be a passive RFID tag, which you receive electromagnetic wave from the reader. The reader has power. Okay, so RFID tag passively stir out by the power and turn the wave into electricity, process the data from the small chip using the remainder power to send the information back. Okay,
Yes,
so
thank you.
not there's when it needs to consume energy, the energy will deplete. It will not be up and running forever without recharging or replacing the battery.
Okay, so efficient power is still an open problem for IoT.
Battery technology is the core technology nowadays. It needs to be used in pretty much everywhere. For the future smart city, because the use of renewable energy, it doesn't follow your schedule. When there's too much sunshine, you have too much renewable energy. If you don't use them, they are gone. And but there are times where there's no sunshine and you need more energy. If you rely on renewable energy sources, chances are you need to have battery technologies. You need to have energy storage system to go with it, to level out the supply of renewable energy. Also with the electric car, if you just imagine everybody, well, these few days because of the pandemic, a lot of people are working from home. So everybody turned on the air conditioner. So suddenly there's a surge on the electricity demand. And that may happen when everybody has electric cars. They go home after work. Everybody says, I need to charge my car. If you don't have a way to cope with that, if everybody is trying to use the electricity from the main grid, I think for sure the main grid will crash. So they need to have a smart way to space out their charging, and also they need to have ways of storing electricity for individual household, so that the vehicle go back, they can use their own electricity rather than from the main grid. So electricity, an energy storage system is an electric car. Imagine that electric car, electric motorcycle, electric buses, all these sustainable vehicles, since sustainable transportation means require electricity. If you don't have electricity storage or energy storage system, the system will not work very well. Okay, so even for Taiwan has a very famous electric motorcycle company called Gogoro. It is already a unicorn company. That is, it worth more than $1 billion US. Motorcycle company start up $1 billion US. Where does that come from? Because they also turn their system into an energy storage system, because their rider need to replace the battery. So they have a lot of surplus battery charging electricity when there's the electricity rate was very low. And when the main grid require electricity, they can even sell the electricity back to the main grid. So the story wasn't just on electric motorbike, although it's very nicely designed and looks very, very good. they have good infrastructure, but another part of their business is, in fact, the energy storage system is that important to the degree that its importance is even higher than their original product and services. Okay, so battery technology is a core tech. In fact, today I had a new student, Peter from Mechanical Engineering Department, ITS Mechanical Engineering Department. He did a very good presentation on the battery technologies and all kinds of optimization problems for preserving the to minimize the mean operating cost of the battery. A very good problem, very interesting. It is a very important area. I think we focus more on our retail, manufacturing, maybe transportation. Health is definitely very important. But now energy is a very important area for conducting research. Energy and sustainability. These are areas where it does have this market there. The market is very dynamic. It's not like power company make electricity and they sell the electricity to you, and nothing else that we can do. It's just buying electricity or you don't buy. There's nothing that you can do. But energy market will be very dynamic. It will be just like our commercial market. There are a lot of research that can be done, a lot of business opportunity and development opportunities there. And similarly for, related to IoT, I mentioned that I do a lot of sustainability research. Sustainability is now a tangible issue, very tangible, because by 2023, European Union is going to tax carbon. If you sell a product in EU and you provide your carbon footprint exceed their requirement, you have to pay carbon tariff. So it is a tangible cost. So we are also measuring the carbon footprint, tracking the carbon footprint for the production system too, using sensors, of course. Tracking and recording the data on blockchain. Okay, so again, energy, sustainability, these are real issues, tangible issues. They are not just for like conceptually social goods. They will be real cost or real profit associated with dynamic market of energy, and also this carbon footprint issue, carbon, and also probably know that by 2050, that's most of the country commit to become a carbon neutral society. So that will cost a lot of money on that. So that's also something very tangible. By 2030, if you cannot stop the growth of your carbon emission, you will pass the point of no return. Even if technology progress, even if you spend more money, you probably won't be able to reach carbon neutral by 2050. So it's not, we are not talking about 2050, we are talking about 2030. Whether or not we can reach a very specific goal. If we cannot reach that goal, there's no point talking about 2050. Okay.
Thank you very much, Professor. Yes, yeah, very interesting. And
Yeah.
Mr. Benjamin said that, yeah, you answer his question clearly. And the microwave example is funny.
Okay, thank you.
Okay, thank you very much. This is such an interesting and insightful discussion. But unfortunately, the time is running out and we must end our discussion today. I want to make a simple summary about today's topic. Year by year, the technology become more advanced and complex. Mechanical products will eventually transform into electrical products, just like computers. An IoT device can be integrated as a system to make a better synergy, to make a better environment for the purpose is for the user. An IoT as a system must have some service and some value for its user. Thank you very much to
Hello,
our
Mr.
honored
Chou.
speaker.
Hello.
Yeah.
Yeah, thank you very much, Professor Chou.
Thank you very much, Prof. Chou. I hope Prof. Chou always healthy. See next week.
See you next week.
I have heard from Emma that Prof. Chou will give adjunct professor for next year.
Yes,
For 2 years. Yeah.
next year, right?
Thank you, Prof.
Thank you
Yeah.
very much,
Welcome,
Professor Chou.
welcome. Very happy to have interaction with all of you.
Okay, thank you, sir.
And thank you, Rara, for a very good summary.
Okay.
Oh, yeah. You're welcome.
Okay,
Yeah.
sir. See you next time, sir. Yeah, thank you.
Terima kasih.
Yeah.
Bu
Okay.
Laras.
So,
Thank
maybe
you.
before we end this session,
Yeah.
may we take a photo?
Oh,
Yes,
sure.
sir.
Participant, please turn on your camera.
So should I stop sharing?
Oh,
Yes.
yeah.
Yeah.
Okay.
Okay. You may turn your camera. Okay, I will take a screenshot for the first slide. And then for the second slide. And then the last slide. Okay, thank you very much for first for the Professor Chou. May I ask what is the topic for the next week session?
Yeah, I think it is already in your syllabus.
Yeah.
Okay.
Okay.
I think it will be about digital fusion. I'll talk a little
Yeah.
on blockchain and AI application.
Yeah.
Digital fusion and AI application. Okay, thank
Yeah.
you very much, Professor Chou,
Welcome.
for sharing your experience and expertise regarding this topic. And
You're
thank
welcome.
you, thank you very much for all of the
Thank you.
participants.
Yeah.
Let me remind you that the next week, we will also have another lecture about the same time, and we will send the information regarding the registration and Zoom link via email. Okay, with this, the
Thank you.
second session of Adjunct Professor is finished. Thank you very much for your attendance. See you next week. Yeah.
Bye.
Bye-bye.
Bye-bye.
Yeah. Thank you, sir. Yeah.
See you
Yeah.
next
Thank
week.
you. Thank you, Bu Laras, Pak Muja. Yeah.
Ya, terima kasih semuanya.
Yeah.
Thank you. Bye.
Bye.